So I'm going to kill
Okay, so
those,
here we're trying out the clock, and now we're trying to set the time. So here we can see that we can set the time to 2 or 3 hours, and then if we press the button, then we switch to minutes. So then we can switch to minutes, and then we can switch to seconds. So now we're back to
yes.
press the button again, then we're back to setting hours.
Is yours commented out?
No.
Then I'm going to just leave it.
Now we're going to try to set the alarm. So we're going to set the alarm to 1 minute, and the first LED should flash. So now we're setting it to 0 hours,
Good.
1 minute, and then 0 seconds.
Because I already have called something different.
After a bit
Because I don't.
waiting.
Because I don't know.
The LED marked as 0 should flash at 1 minute.
I don't have core time, but this doesn't use. Why does set time top use core time?
Because it's 0, it's fine. Yeah, you're fine. It's fine.
There we go. So it's flashing. Now we just turn off the alarm enable, which is the last switch, and the alarm should go off.
Hello, Will here, going to go over some of the more interesting bits of the code now. I'm going to be going over pretty much only the finite state machine for the clock here, because the 7-segment decoder really did not change at all between Lab 3 and now, because it could pretty much already display everything we needed it to. So here's the top module for the finite state machine. We've got inputs and outputs and plenty of registers for later. First, we call another module a debouncer for the one input button, confirm, which is how you select time to put for either the alarm or the clock itself. And here we have a clock divider for the actual clock. And this clock divider, as you can see, divides what should be a 50 megahertz clock by just a little under 50 million, which makes it about a 1 second clock. And using that clock, here we have initial block saying everything to 0. Using that clock, we count up seconds equals seconds plus 1, incrementing each second of the clock. Then once we get up high enough, seconds turns to another minute, and seconds goes back to 0. And the same thing with minutes and hours once minutes gets to 58. You'll notice there's a bit of a difference in the naming convention. Clock hours is the 24-hour time always, but since you can switch between AM and PM, it is not always the direct output of the finite state machine. And down here, we have a little bit more logic for that. So if the user has turned on the 12-hour mode, we have a couple different logical statements to show how the 24-hour time should change to 12-hour time. And AM here is a little binary bit that says, if it's 0, display an A for AM, or if it's 1, display a P for PM. Next, we have a large case statement with 2 case statements inside of it, one for inputting a time to the clock, and another for inputting a time to the alarm. Here's some old code and comments, ignore that. And here we just have an always block for confirm, which increments a counter called switch, which goes back to these case statements here, and goes through the hours, minutes, and seconds. And finally, just a little bit of a logic left for the alarm. So if the user has enabled the alarm with a switch and the times are correct, we put alarm set to 1. If at any point the user disables the alarm set goes to 0. And alarm set goes into this module called LED, and alarm set is the enabler for it. And once it is enabled, we have LED out, which constantly blinks on and off every second.
So the successes and failures of Lab4 for us were, we managed to get the clock to count at 1 second, or it was near to 1 second, but it looks like 1 second. So That was good. Another one, we managed to get the LED flashing when we set the alarm, and we managed to change the time from 24-hour clock to 12-hour clock. A few failures were that we couldn't get the sound to work, and we didn't really know whether it was an issue with our clock or whether we didn't really play the sound correctly. But I think eventually I found out that it was there was no speaker on the FPGA, so we had to bring in headphones, and unfortunately I couldn't find any within our aux. So that's that.